Hi everyone, welcome to Kotlin London. New year, new event. We're still hoping to have a physical event any time in the year, but definitely won't happen anytime soon. So we're still committed to our monthly event. We're actually looking for expanding our um, our events. Let's see what we're going to do this year. But for now, we have our monthly events. This is January one. I'm trying to uh, start with a bang. Um, Definitely thank you to our 47 Degrees, who is our sponsor for this meetup and for the next meetup. Check out the academy with a lot of coursing on Kotlin and functional programming. The links will be provided in the description below. And of course, thanks because one of our speakers today is for 47 Degrees, and they're talking about functional Android. If you want to try StreamYard, or you know someone who wants to try it, use the link below. So you get a discount, but we also have a referral, so you get a discount to help us to get some money to run the meetup. If you haven't done it yet, join meetup page, hit subscribe on YouTube, and follow us on Twitter. Speak also to friends and colleagues who are interested in our talks and might be interested also in speaking and giving talks. So as usual, we have two talks. We have two Jorge tonight. The first one is Jorge Rego. The second one, as I said, is Jorge Castillo, functional Android. We'd like to thank them for accepting to speak to our meetup. I think that's it. Oh, yeah. QA will be done after each talk. We provide the link in the description or in the chat on YouTube. During the talk, as usual, please add a small feedback in the comments, just a thumbs up. That would be enough. So the speakers know they have some feedback, because sometimes it's very difficult to have feedback when we're speaking online. So I think that's it for me. And it's time to, our first speaker is, as I said, Jorge Rego. We're talking about Ktor, and especially his architecture proposal to build the servers with Ktor.
Okay, can you hear me, guys? I hope yes. Okay, I will switch to the presentation. If you cannot hear me or if there is something wrong, just please let me know and I will try to fix it. Thanks to Enzo for this nice presentation and all the effort that they are doing with this group. I think it's pretty cool. And I will start the talk now. Hi, all of you. Welcome to this talk about Ktor and some proposal of architecture. I hope you are all doing fine with all this pandemic going on all around the world. Difficult times, but let's try to make this talk interesting. So let's start, and let me first introduce myself. You might not know me very well. My name is Jorge Rego. I'm currently a senior Android developer at Posit.com, and I'm also responsible or the developer of Ktor Easy repository at GitHub. It got 32 stars in the GitHub. It's such a not expected success for me. I think I got really positive feedback about that. So I said, well, let's prepare a talk and let's share this with the rest of the world and get more feedback. So all the examples that you are going to see in this talk are available in my GitHub account. You can see it in there. And also Ktor Easy is available in my account. Also, I'm writing some articles about Ktor and this architecture and testing at medium.com. You can check my profile there if you want. And I think they are really interesting articles to achieve a deployment of a Ktor server and also monitoring and other things. So if you are interested, you can check it there. Okay, so let me introduce the index that or the topics that we are going to discuss during this talk. First of all, I want to go through some architecture introduction and overview, where I will briefly talk about this architecture proposal and some of the key aspects of it. Then I will move to talk about a bit about the layers and responsibilities of each layer. So you can see the layers there. We will see them in a diagram just in the next slides. Then I want to talk about dependency injection, because I think it's a key concept that we want to talk. In case you didn't hear about yet, I think it's something that we need to discuss. And then I will end the talk talking about how to properly test this architecture, because I think testing is an important part of developing our servers. Okay, so let's start with the architecture introduction. Let me start with saying what this architecture and talk is not, and what this architecture is. So I will start with what this architecture talk is not. This is not a standard way to build servers with Ktor. I'm not trying to convince anyone to just follow this approach. There are more ways of developing Ktor servers using other platforms and technologies. So pick the one that fulfills all your needs. This is just one approach. So try to find the good points and the bad points, and then choose wisely. I'm not a senior backend developer. I'm an Android developer. I know something about backend, but I'm not an expert. So don't expect maybe the best naming references or standard ways of dealing with things, because I'm not a senior backend developer. So please forgive me for that. This will be a top performance server. It's a Java program. At the time that I was creating this and using Ktor, there was just the Java version of the server. So this will run in the JVM, and we know that it's not the fastest in the world, at least not that fast as Node.js, Go, or others around. But yeah, nobody wants to code in JavaScript, right? So this is another option, let's say. And I won't show how to handle small things in this talk. I think the documentation and community around Ktor are really nice, and also Kotlin. So if you find yourself stuck, you can always ask the community. They are really nice people, and they will solve your doubts for sure. Okay, now let's move to what this architecture is. I think it's a clean approach to build servers with Ktor. It can be better, but help me to build it in a better way. I think it's useful reference. It's a useful reference for Android and Kotlin devs to implement backend solutions. Yeah, I found myself trying to develop my backend in Node.js, and after a couple of weeks, I found myself trying to killing myself after reading the code. So yeah, I think this is a nice approach to start writing backend solutions. It's another option. Also, I did this to try to demonstrate a bit that Kotlin backends works nicely in a production environment. Currently, my server is running multiple instances of Ktor, and I had no problems at all. The only problems were related with my own bugs. So I think it is saying quite a lot about the technology. And I think it's an option if you want to have a maintainable, testable system. We all know what happens when the system grows, and I think it's better to be prepared to maintain them. So if you get an architecture that is maintainable and testable, I think that will make your life pretty easy. Okay, so what are we aiming for with this architecture? Basically, split responsibility in layers. Each layer should be responsible of achieving something within the scope and nothing else. So dividing responsibilities will help us testing, developing, and aligning with the rest of the team. Also, we are aiming to inject dependencies. We will talk about dependency injection later to explain you a bit deeper what this is. But just to introduce this, if you want to make your code testable, each layer should get its dependencies injected. We want to connect by interfaces. In order to inject dependencies, those dependencies should implement an interface, and also it will help on testing and disconnecting the different layers. We also want to make it easy to adapt or change. So we all know that implementations can change over time, so better be prepared for that. So this should be a crucial thing to include in our architecture. And also an important point for me is that using our architecture, defining our architecture will allow us to have a well-known structure, and the team will speak the same language. So if you make this architecture clear for the entire team and you make it a convention, then all the team will follow, and it will help on recognizing the different layer responsibilities and how to structure your coding. And also, if you're working with a PR system, like GitHub, for example, then it will help on reading the code, understanding, and then getting the PRs merged faster, I think. Which libraries are we going to use? So basically Kotlin and Ktor, obviously. Gradle, you can also choose like Maven, but I prefer to use Gradle. I think it's easier for Android devs to switch and keep Gradle as the build system. Yeah, we are going to use as well Coin as our dependency injection tool. Yeah, we will see later that it's not a real dependency injection tool, but later we will discuss that later. Actually, we will use Coin Ktor extension, a specific extension for Ktor that integrates pretty well with Ktor. Also, we will use Exposet, that is going to be used for connecting to the database. And in testing, we will use JUnit 5 and Mock-K, and maybe some assertion library. It is not really important to mention here because just to make the assertions. Okay, so this is the architecture overview with the different layers that I have implemented. Let me go through the different layers and explain briefly what they are responsible for. Basically, the application Kotlin file will be responsible of starting the Java app, also recovering the config, initializing Coin, and starting the Ktor engine. The module Kotlin file is going to be responsible of Ktor feature and module installation. We will see later an example on what is happening inside. There are more things happening there, but just a brief explanation. Then we have the different modules. These modules are the root definition classes, are extension functions of routing, and I normally group them. One module will represent the different CVPs routes. So let's say that module A can be user module, and then all the routes based or used for users are going to be in this file. The next layer is the controller layer. So this is where all the business logic is going to be, and this has a relationship with the modules with one-to-one. So each module will have a controller to deal with the different routes that are being triggered. Our business logic will need some support from APIs. So controllers will have access to the different APIs to fetch data and store data. And the different APIs will have some data access objects to communicate with the database. So these are the different layers that are present in this architecture. Okay, let's go a bit deeply about the layers and the different responsibilities. So basically, the application layer or the application Kotlin file that we saw before, it will be responsible of starting the Ktor application, the engine, and the port. It will recover the Hokun config from the file. It will start going with all the dependencies that are required in the app, as you can see in the big square in the middle. We will call the main function that will trigger the function in the module layer. So basically, this small main function that you can see there will be calling the big module Kotlin file that you see there. And in this layer, there is not business logic at all. So don't place business logic here because we will place it in a different layer. Okay, so the next one is the module layer. As I mentioned before, it's going to be responsible of installing application features and interceptors, also the routes and status pages and other features that our server is going to use. As you can see here, no business logic again. This is not the place to put the business logic. This is going to be, the business logic is going to be placed in the controller. If you can see at the bottom, the routing is being defined here, but we are calling the different modules, the CBP modules that we are going to see after this slide. Something like a registration module, authentication user module inside the authenticated path. So yeah, let's move to the module CBP. So in this case, I had a screenshot of a registration module. This is one of the CBPs that I'm using to register users. So you can post users, you can authenticate, and you can generate tokens. The responsibilities of this layer is, of course, defining the routes, as it is a function extension function. For routing, you can use the different methods to define the routes. So you can use post, delete, get, update, or put. And you can. Another responsibility of this layer is receive the different parameters that are being recovered from the root. And then when you have the parameters, you delegate everything to the controller where the business logic is, and then you get back the successful response. As Ktor is working, in case of something is going wrong, you can throw an exception, and then this exception is going to be handled by status pages. No business logic here again, because we will see business logic in the next layer, that is the controller layer. Okay, controller layer. This is one of the biggest layers, of course. This is handling all the business logic. This handles transaction start end with the data DB query block that you can see in the middle square. You can also map models from your model objects to the response objects in case you don't want to send all the information that is defined in your model objects, such as passwords or other stuff. And this should implement an interface. As you can see at the top right, registration controller is our interface. And you might be thinking, transaction database logic at business logic layer. It's a bit weird. I've been thinking about this, but after thinking it for a while, Ktor way of working with throwing exception, being catched by status pages. So handling transaction at this level seems convenient, because if you want to roll back some operations, or if you want to control which operations to roll back and which one should stay, then I think this is going to be defined by your business logic. So I think it makes sense to drop this transaction control here. There might be better ways of dealing with this, of course, but I didn't have the time to figure how to improve this. If you have suggestions, please let me know. And you can also fire a PR in my GitHub repository. All PRs are welcome, and I will discuss with you if you consider it is important to include them. Okay, let's move to the next layer. So API layer, responsibilities, fetching and storing data from and to one or many sources. Yeah, just using data sources to or data access objects to fetch and store data. It can also happen object mapping. So if you have a data access object that is returning object entities, different model from the data access object layer, you can map it to your model layers or model objects. This layer should throw its own exceptions, because if you want to disconnect the different layers, you need to create your own exceptions in this layer, and should also implement an interface. So as you can see at the top, user API is the interface that we are using here. Okay, so data access object. The responsibilities of this layer is, as we are using exposet, it's defining the table as well, not only providing the methods to fetch and store data. In this layer, in those methods, we need to map databases, database rows into entities. So the model that we are returning from the data access object should be converted from the rows that we are recovering from exposet. And it also needs to implement an interface. As you can see at the top, user data access object or user DAO is our interface. Okay, so yeah, we are in the dependency injection part. So what is dependency injection? It's a complicated term or idea. So basically, it's a design pattern where an object receives other objects that it depends on, and which dependencies implementations to be received are defined outside the object using them. As we saw in the previous part in this application layer, the initialization is defining which implementations are going to be provided to when an interface is required. So in this case, if we want to recover a database provider contract, as you can see in the line 13, then we will provide a database provider object. So this is what means external provider for dependencies. Okay, and which advantages of using dependency injection are we going to get? Basically, layer isolation. So if you provide the dependencies from the outside, you can provide whatever implementation you want. So while testing, you can use those for mocking as well. It will improves reusability. So if you have a dependency already available, you don't need to implement it again, and it will change your mind a bit to always think if that dependency is already provided. So it will improve reusability. And it will also reduce boilerplate code, because some of the object instantiations are going to be painful in some cases with a lot of fields to fulfill. So if you have that already in place with the dependency injection tool, then you just need to call inject, and then you get that object instantiation with all the fields. So it is going to reduce a lot of boilerplate code. And I want to end this part mentioning a tweet from Ken Beck. If you don't know Ken Beck, you need to Google it after the talk and check who is this guy. But basically, he's saying that dependency injection is a lovely example of Jevons paradox. Yeah, you might not know what the Jevons paradox is, but let me explain it to you. Basically, Jevons paradox occurs when technological progress increases the efficiency with which a resource is used. And by reducing the amount necessary of that resource to any one use, the rate of consumption is increased. So the demand of the resource is also increased. So basically, dependency injection increases code reusability, reduces the number of needed tests, and makes them easier to be done. And this makes testing easier to be adopted and so to write more tests. So this is helping on defining or happening the Jevons paradox also with testing by applying dependency injection in our architecture. And something that I mentioned before, we are using Coin. There is a difference between dependency injection versus service locator. Coin is not a real dependency injection framework, but a service locator. There is a tweet from Jake Wharton here in the link that you can check where he's explaining the differences. But basically, service locator is not really checking that the dependencies are being fulfilled in compilation time, but dependency injection tools are doing. And also there is an overhead of using service locator because it is a bit slower in theory. So yeah, in some technologies like entry, this is going to be important, but in Ktor, as the overhead is being placed when the server starts, this is not going to impact us that much. As I mentioned there, we are using here Coin Ktor extension that is working really good with Ktor already. I think it's pretty useful for us, and the drawbacks of using it are not that much. So I think it's a good tool, even though it's not a real dependency injection tool. Okay, so let's see how the dependency injection is happening in the architecture. Basically, we are starting injecting from the module CVPs onwards. So module A, or user module, or whatever we call it, is getting the dependency injected. So controller instance is going to be injected in module. The same is happening for the controller, getting the APIs injected in the controller, those dependencies that controller needs. And the same is happening with APIs with the data access objects. In case of database, data access objects have a dependency with the database, but Exposet is managing this dependency by instead of allowing us to do it. So it's easier. And all objects that are injected have to implement an interface. This is crucial for later on disconnect the different layers. And that is basically the structure that we get after integrating the dependency injection in our architecture. Okay, and now we are reaching our lovely testing part. I hope you enjoy this part because I think it's quite important. Okay, before starting, let me give you some advices about testing. You might know this already, but I think it's good to share with everyone. So let's start. So think before start coding your tests. So to be successful at testing, you really need to know what do you want to test. This is crucial. So design your test cases properly, understanding which layer you want to test, which dependencies you need to mock, and which values you need to provide to simulate the scenario that you want to test. And if you do this, you are going to get really nice tests. So remember, think before start coding your tests. Don't try to achieve 100% of coverage. Yeah, that's the dream. But if you can always achieve 100% of coverage, you are dreaming and you need to wake up. It's not the real world. If you are in a company and you are working in real life projects, you have deadlines, you have CVPs deliveries, you have some schedule. You most likely are not going to be able to fulfill 100% of coverage. My advice, define a proper testing plan, prioritizing those layers that have crucial logic. I think this is the most important. So just prioritize what is the most important to be tested. Define your instrumentation. What do I mean by instrumentation? I mean test data objects, abstract classes, extension functions, whatever it is going to be useful for you when creating your tests. So better be prepared for the long run. Don't just place everything in your tests and leave it there, because at a certain point, that is going to make it harder to read, to change, and to maintain. Maybe the first week is going to be painful, but after that, I think you won't regret to spend time doing your instrumentation for testing. Yeah, remember the Jevons paradox that we mentioned before. If you make it easier, it is going to be easier to be adopted by the team, and then that will increase the number of tests, and then you will get a higher quality product. And I think this is key when you try to deliver a high quality product. Not all layers should be tested with the same tools. Some tools, like, for example, the test application engine that Ktor is providing, can be restricted to be used only in external layers. So you don't need to always make use of this and always use a test application engine to test all your layers. You can restrict that to the most external layer in your module, CVP modules layer, and then the rest of the layers can be just unit tested without the need of using that tool. Even when it is a nice tool from Ktor, you can make your life easier just getting rid of that in the rest of your layers. Using a good architecture will help you to test properly. If each layer has its responsibilities, its dependencies are injected, and you properly abstract them, you will be able to properly unit test each layer. And if you can unit test each layer independently, that will help on asserting that the layer is working properly. Of course, later you need to do some integration tests and some other type of tests, but yeah, this will always help on isolating, and this is key. This is key when you want to test your different layers. And test cases must serve a purpose. Writing tests is kind of cool right now, but you have to run them. How can they bring more value? You need to, for example, integrate them in your continuous integration pipelines. You can also get peer approval checks with integrating your tests. Or maybe after each branch push, you can run your test to verify that everything is fine and nothing is broken. You can choose many options, but please run your tests. If you write them and you leave them alone, they are not bringing value. And this is one of the key things of creating your tests. And these are some of the advices that I wanted to share with you related with testing. And reaching this point, you might be thinking, why am I telling you so many things about testing in an architecture talk? Yeah, correct. Some of the possible answers to this question can be A, I want you to suffer. B, I was a QA engineer before, so I need to show off. Could be. Or C, testing should be part of your responsibilities, so better prepare your architecture for that. Yeah, obviously is the option C. When designing your architecture, you need to consider testing if you want to deliver a high quality product. You should not change your code, such as visibility modifiers and other stuff, to make it testable. But you can always adapt your architecture a bit to making testing easier for your team. And this is what is important when talking about testing and architecture. Okay, so now before moving to some layer testing examples, let's recap a bit about the architecture. So this is the last diagram or the last architecture example that we saw with the different layers and the injection happening between the layers. So I'm going to start from left to right, starting in the modules layer, and then I'm going to move onwards until data access objects. We are going to test our business logic, abstracting it from app initialization. That is why I'm starting from the module onwards. If we want to test application module layers, we can use other tools such as API testing tools like Rest Assured, or using the test engine from Ktor. But we need to see how to disconnect and how to work with these layers in a different perspective, and maybe using other tools. So let's start with the root testing. So the module A, module V layer. So to test this layer, I'm using the test application that the test application engine that Ktor is allowing us to use for testing. It is encapsulated in with-based test application. That is a function that is part of my instrumentation. It is also in the test, you also need to install your roots in the test application engine. This is happening as well in the instrumentation. It is not in the screenshot, but you can check all of this in the repository in GitHub. If you are curious and you want to know more about all the instrumentation, it is already there and you can check. After that, we are mocking our dependencies, such as registration controller. We are defining what should happen to recreate the scenario that we choose to test in this case. So return the response user. We are triggering the root by defining the call and the path that we are calling here with the parameters or headers and the body. And then we are asserting what is the expected result from the response in the call or from the other different values that are inside the call that we are recovering. And this is how we can test our root layer or module layer. If we move to the controller testing, we have our tests. And in this case, the controller is going to be our sister under test. So the real object that we are going to call the methods, and then we are testing the code that is inside the controller methods. So basically, we are again mocking our dependencies, line 49, 50, where we mock API calls with expected return to recreate the scenarios. Then we use the run blocking for coroutines, and we call the real method for the controller to create the user. Then parameters are recreated as they are passed from the module layer or the root layer, and then we assert over the return we get from the controller. Assertions can also happen against the mocks to check that they are being fired or that they are being called number of times, and also you can check that there is that the method is throwing an exception, not recreated in this example, but I think there are other examples in the repository to check if the method is throwing an exception. And this is how we can test our controller layer. API. This is a really easy layer to test. Again, mocking our dependencies that are the data access objects. Then we call the API object, a real method, passing the parameter, and then we are asserting over the response that the API is returning to us. We can also assert over the mocks, and we can also assert if the method is throwing something. Really easy to test. And finally, we are reaching the data access object testing layer testing. In this case, we are testing our data access object. Then we need a database in memory. That is part of the instrumentation. It is not reflected in this screenshot, but you can check the repository to see how this is working. And we are starting a transaction block because we are doing real transactions over in-memory database. We create the schema. Normally, when you are testing your systems, you need to recreate the environment. So you create the database, and then you need to create the different tables that you are going to use in your tests. So this is what create the schema is doing. It puts all the user table inside the database. And in case you need to inject some fixtures, you also can do it in there. And once that we create the schema, we call the method that we want to test, and we do our assertions over database state. So we are using getUserById to check the database state. And then we assert that the user that is being returned is the one that we inserted. One note to say here, basically, create a schema is being integrated inside this transaction block. As you can think, this create a schema can go to the setup method in JUnit. I tried to include this in that method, but I don't know why it was not working. So I had to integrate the create a schema inside the transaction block inside each test. It's not proper, but I didn't have the time to go deeper and investigate a bit further. If you find a way to make it work or a different way to make this create a schema, then please let me know or fire up PR in the repository. I will be really happy to see how this can be done. And yeah, I think this is all related with the presentation. And yeah, thanks for watching. If you have some questions, please don't be shy.
Let me share the Slido. Just give me a second.
Yeah.
Yeah, we have just one question. Can you see it? Okay, perfect.
Yeah, I can see it. Can we split the different business logic? I mean, it routes into their own modules coming from the multi-module Android side. Business logic routes into their own modules. I don't really get the point. Maybe if the one making the question can explain a bit more.
In the meantime, there's another question in the chat. So what if you annotate the setup function with JUnit method before each, then create the schema before every test probably?
Yeah, that is what I was.
Yeah.
That is what I was talking about. I try to do it in that way, like preparing. You always need to prepare your tests. Grouping all the setup functions, like create a schema in your before each. I tried to do it, but as it was out of the transaction, even I tried to create a new transaction after the database in memory was created, but it was not working. When I was running the tests, it was saying that the table was not there. So in order to make it happen, I had to move the create a schema inside the transaction, inside the test. Didn't have the time to go deeper. As I said, if you want to investigate, I'm really happy. And if you find a way, please fire a PR. I'm going to be really, really happy to see a PR in the repository.
New question.
Yeah. Can you have multiple Gradle modules in Ktor? Yeah, I think you can. I think it's like a regular Gradle project. You can have multiple modules. I'm not sure how they fit each other or how to include them, but I think you can have a module for common logic, and then you can have multiple projects or multiple servers. I think so.
Perfect. If there are no more questions, I'll say thank you so much to Jorge. And yeah, very interesting talk. Thanks so much.
Thanks.
So let's go straight to the second speaker. It's another Jorge. It's from 47 Degrees, and we're talking about basically the main topic for 7 days once is always preaching. It's functional, and especially functional Android. Gets to Jorge Castillo.
Hello, can you hear me?
Yes.
Okay. Okay.
Hear you.
Okay. So are the slides already visible on the screen? Okay, I see them now. Perfect. So thank you very much to Kotlin London and all the organizers for letting me be here today. It's a big pleasure. I really wanted to be part of this event last year, but it was almost impossible for me. So happy to be here finally and to have this chance. Thanks for inviting me. Thanks to all the people watching. I'm Jorge Castillo. I'm an Android and Kotlin Google developer expert, and I'm part of 47 Degrees. I'm one of the parts of the pieces of the 47 Degrees Academy, which is the platform we use for teaching people, developers around the world about functional programming, and also not only functional, but platforms like backend, mobile, and much more. So if you're interested, feel free to browse the website in the 47 Degrees site. And that's pretty much it. We are going to talk about functional Android today. So it's functional programming applied to the Android platform. So we will go over like a lot of different concepts we find in the functional world applied to this platform. So let's go already to the content. The first question I will make myself before picking a new paradigm is basically why. So why functional programming? And what it is. When I personally think about functional programming, I think about determinism. So it's one of the ultimate goals of the paradigm to try to achieve determinism over our code bases to make them more predictable, easier to reason about, and also easier to test, obviously. So the paradigm is going to help us on that. And that obviously means that we are not going to be very friendly to side effects, right? So side effects are always present because Android is basically an effectful platform. We need to show the stuff on a screen. We need to query network. We need to query databases, read from files, and so on. So, I mean, the side effects are going to be there, but we want to get them under control. Okay, so that's going to be like the ultimate goal of all this. So it's not so much about getting rid of the side effects, but more like getting those under control. So another very interesting thing is the concern separation. And concern separation is something that is really present in the functional world, but not only in the functional world and functional APIs, but also on many other APIs in different platforms and libraries out there. So it's this idea of having the chance of kind of writing our program, we could say declaratively. So what you are creating is more like a description of a program, and then you have the chance to consume the program later on. And that's where you decide how you want to consume the program. So there is this differentiation between what we usually call the algebras in the functional world, which is basically our pure functional logics, so the logic of our program. And then the actual runtime. The runtime is the moment where we finally or ultimately execute or consume the program, right? And that's really important because that gives us the ability to reason about how the program is written before consuming it. And we can then, therefore, apply different optimization mechanisms or, decide how we want to consume it. In the world of Kotlin, you can find Kotlin sequences, which is actually using this concept, right? Because they provide you these lazy operators that allow you to compose the logic of your program, or at least the logic that is going to be working with the sequence in a kind of lazy way or declarative way. So all that code is not going to be executed until you decide to consume it in the end. So there are some terminal operators in the end, which are the ones in charge of actually consuming it, right? So before that point, everything we could say stays like cold, maybe we could call it. And declarative, it's more like a description of our program, but then you have a terminal operator to decide how you want to consume all that program. And at that moment, I think it's really interesting because that's the moment where we can not only pick how you consume it, but and finally execute the whole thing, but also maybe apply optimizations like decide, I don't know, since you have like the whole picture in memory of how the program looks, at that point you can decide if you want to skip different parts of it because they are redundant, or maybe you want to offload different parts of it to different threads or contexts, or even parallelize the execution of different computations that compose that program, right? So in that sense, having this concern separation gives us the ability to have the program in memory first and to see the big picture and then decide how efficient we want to be consuming it also. But we can also find it in the world of Android. So Jetpack Compose is also using this idea. Compose is a pretty new platform, but if you dig a little bit into the sources, you'll probably find out at some point that they are kind of having this slot table, which is like a representation of how the UI looks at any point in time in memory. So what they have is like an in-memory table or a structure that is holding all that information and metadata that is able to represent a given state of our UI at any point in time. So just by looking at the slot table, the library is able to later on interpret or consume that slot table and materialize actual and real UI from it. So in that sense, they also have this idea of concern separation, because based on what's on the slot table or that in-memory structure at any point in time, they can also apply optimizations like things like smart recompositions for skipping recompositions when the data you need is already stored in the table, so you can just grab it from there and things like that. So also ideas like parallelizing compositions and things like that that might be coming in the future, even if they are not possible now. But overall, they are kind of leveraging this idea of concern separation also, even if that's only for them within the library. It's not something you can make use of it as a client at this point. So I wanted you to peek a little bit into the composable functions, because they have a lot to do with suspend functions, or are really similar to the suspend functions. And those are, the later are going to be really important in the world of how we flag side effects in functional programming. So I want to go over both types and compare them a little bit. So composable functions, we can say that they describe an effect. It's a function that describes how the UI is going to look whenever it gets displayed or rendered, we could say. But it's more like a description of that. It's not yielding actual UI when you execute it. What they ultimately do is emit changes over the slot table. So there is a little bit more complexity there, but you can understand that the actual composable function is not defining or creating a view, but defining how the view will look like. Not the view, but the UI component, we could say, will look like whenever it's finally materialized. So it's more like a UI effect, we could say. But the cool point here is that they are not callable from anywhere. You can only call a composable function from another composable function, or the integration point, right? Which is the same set content call where you're going to feed all your composable logics. So in that sense, they create this restriction that kind of crawls up your call stack, because if you flag a function as composable, then you can only call it from another composable function, and that one can only be called from another composable function. So it's like a requirement that will keep crawling up your call stack until this entry point of your program, that is the integration point with the platform, we could say. Obviously, that's giving them, the team, the certainty that it's all gonna be like a composable function call stack, one after another, so they can ensure that they cannot take the compiler and replace all those functions in the call stack by new versions of them that automatically pass this composer implicit parameter. So in that sense, they just want to ensure that context all the way, so they can pass the composer around across all those calls, and that's what will ultimately drive the composition and how compose library works. Another cool point of composable functions is obviously that they are compile time tracked. So this is the same thing again. You cannot really call them from anywhere. The compiler will not really allow you to compile when you're trying to call them from wherever, but only when you are calling them from another composable function, right? So this is basically us flagging UI effects, so the compiler is aware of those. So the compiler is already giving us feedback about how we call those effects and from where we call those effects. So that's giving you a lot of safety of how you're using or calling your effects at compile time. So that improves a lot the feedback loop and makes sure, be sure that you are using them correctly. In the world of suspend, we have the same idea. So they almost map one-to-one between each other. So the suspend functions are also describing an effect. In this case, it's any type of effect, not necessarily a UI effect, which can also be. They also impose this calling context restriction that is going to crawl up the call stack, because if you flag a function as suspend, the compiler will make sure that you cannot really call it from anywhere. So you are only able to call this suspended effect from other suspended context, another suspended function, or a coroutine, which would be like the integration point in this case. That makes sure that what you have is a suspended call stack all the way edge to edge, and that makes sure that the calling compiler can basically implicitly pass this continuation parameter across all those calls, right? And that's what drives how coroutines work in the Kotlin runtime. So the compiler is again keeping track of those effects. It's the one that is going to decide where you can call a side effect and where you are not allowed to call it. So it's basically the same idea. So we could say that they are reusing, in Google, they are reusing the same idea of suspend, but for a different ultimate goal, we could say, in the case of composable functions, right? But this is really important because suspend functions are, because of this, a really good way to flag side effects, because that's going to make the compiler aware of what is a side effect and how you are calling it in your code base. So let's start using it in our favor. Let's start flagging our effects as suspend. Let's imagine we have a few, I don't know, network service, a network service, a persistence database, and then an analytics tracker, for example, so or whatever. So you can imagine any type of side effects that you can have in your program, you could flag them with suspend, and that's automatically going to tell the compiler that you cannot really call them from anywhere. You're adding this restriction, which is really important because that's giving us and the compiler certainty about how the side effects are used in our program. But obviously, we are going to need a runtime, right? As we were saying, we impose this calling context. So at some point, there is this integration point we will need for running our suspended code base inside. So we are going to need to create a coroutine. In the world of Kotlin X coroutines, this runtime for our suspended program, or this environment for our suspended program, is basically created using the coroutine builders that you can call over a coroutine scope, and you can make use of the structured concurrency and all that. So you can invoke, create these child jobs and all that kind of stuff. So you're using Kotlin X coroutines, you could basically put your suspended program in there. That's the integration point in this case. That is interesting, and Arrow, the Arrow functional library in Kotlin, is providing a lot of functional operators that will work seamlessly on integration with Kotlin X coroutines, starting on version 0.12. So we are going to provide direct integration with Kotlin X because it makes a lot of sense, given it's a library that is obviously everywhere. So it doesn't make a lot of sense to fight against it, but instead provide good means for integrating both of them together. If you are still on 0.11 or older versions of Arrow, you have the environment also. I mean, you can create an environment by yourself, which is what Arrow provides to create this kind of a safe environment or environment prepared to run suspended programs. So the environment will give you the ability to pick how you consume the suspended program. So we are talking about concern separation again, right? The environment will give you the ability to pick how you consume it in terms of whether you want to do it in a blocking way or non-blocking way, or if it's going to be sync or async or cancelable. You pick the execution strategy with it. Also, you can pick the context for what you want to use for running the program. And yeah, you can put your program in there and run it. This, for example, is the async cancelable execution strategy that gives us a disposable that then we can invoke later on whenever we are ready to cancel the whole execution tree, right? So all the child jobs that are created hanging from this kind of root element, which would be environment, are going to get canceled. So that is how you can do it with 0.11 in Arrow. But as I say starting on 0.12 and ahead, you are going to have the chance to integrate it directly with the coroutine builders and Kotlin coroutines. So it's going to be much easier for you to integrate it in the code bases where you are already using Kotlin X, most likely. So the runtime picks the execution strategy. As I was saying, it picks the context for on what to run the actual suspended program, or where you want to consume the suspended program. And it also has the chance to apply optimizations when consuming the program. Cool. So about the entry points, there is always like an entry point to a program. In the world of Android, we don't have like a main function to run our app, but it's more like we are given these callbacks in the fragments and activities lifecycle. So we need to fit also the views. So we need to fit our logics in there on those callbacks. So those entry points are definitely not suspended. And in that sense, we are going to need to create a coroutine by ourselves to run our suspended program in there, right? So in that sense, in Android, you will be enforced to either use the coroutine builders or use the Arrows environment. But you need a means for creating this environment or runtime that is essentially prepared to run or to consume suspended programs inside. If we were using another platform like backend, and maybe we are using Spring or Ktor, some of these platforms provide you the ability to create suspended entry points. So you have the chance to declare your endpoints as suspend functions, which basically is giving you this environment already built in or right out of the box. So you don't need to create the coroutine by yourself. You can just go ahead and put all your suspended logics in there. But in the world of Android, that's not going to be the case. So, well, we have this idea of concern separation. We know that we want to use the suspend keyword for flagging our effects. We know that we have our this sense on the requirement that we will be imposing by using suspend. So that will crawl up all our call stack. And at some point, we will need to create the coroutine for running all that suspended code. So that's going to be the entry point. We have this idea. So we have the entry point. We have a way to flag side effects, to keep them pure by using suspend with this requirement. But we have still not looked on, to how to encode the actual logics of our program. So the data types are going to have a lot of, importance here. Because data types basically are used for wrapping our data, and then they raise a concern over our data. So we will be using different data types, but either is going to be a very common one, and you will see in a second how it works. But it's based on this idea of railway-oriented programming. So we are talking about programs that have two rails, right? If we think about any program out there, any computation in a program, it can always go well or wrong. So it either succeeds or fails. And you can represent that as a couple of rails that your computation might follow, right? So you can think about your function, something like this, right? You have a function f that might potentially succeed or might fail, right? So you have two possible rails, two possible paths that the execution could take. That's called, you can think about programs in that way as a composition of functions that might fail or succeed. And that's called railway-oriented programming. It's a concept created, I think, or defined by Scott Woleski back in 2013. So it's a pretty old concept, still very, very, it still applies, it still makes sense. And there is this talk and this post that I'm probably going to share later on, I don't know, on Twitter or somewhere, So you can also click on it. It's very interesting for digging a little bit more on this concept. So either is going to be a big player here in the world of functional code bases, and it will give us this kind of duality for our computation. So there's always going to be a path we want to follow versus an alternative path, the happy path versus the error path, we could say. In the world of Android, it is going to be exactly the same. Any computation might go well. It might succeed or fail. And the happy path is likely the one we want to compute over, where we assume that everything went all right, we were able to retrieve the information we were looking for and all that kind of stuff. So we can keep computing over it. So that's the happy path. In either, that's going to be the right side, and but you will see it in a second. And the left side will contain the errors, which is going to be like this alternative path we don't like that much. But either will make it explicit that the computation might either succeed or fail. So this is all about making that duality or disjunction explicit all the time. So whenever you are going to process a result that is wrapped into either, you are always going to be enforced to think about this duality and maybe also enforced to handle both sides. So you don't forget about any of those, okay? So this is either, it's obviously an intentional oversimplification, but you see how it's a sealed class with two possible implementations, left and right. Left is going to contain a value of type A, right is going to contain a value of type B. We can assume that right will always contain data and left is where we are going to put all our errors by convention. And then you have map, flat map, all that kind of operators that we are familiar with already, most likely. So fold is an interesting operator that you have that basically gives you the ability to handle both sides, because you never know if the either is going to be a right or a left at any point in time. You need to check for the type, and fold is basically doing that. It's like a when statement that allows you to pass lambdas for both sides. So depending on the side it is at this point at runtime, if it's a right or a left, it will run one lambda or the other, right? For example, here we load a user. Let's say that goes to network and returns a valid user. In this case, we are mocking the result. It's going to be a right wrapping the user because it succeeded. So we use right to reflect that. We wrap our data into right, and then we can fold over it to the side what to do with it. In this case, this is the lambda that will run. The other one will not run because it's a right, okay? So we can render the user in this case. So fold is cool because it's basically how you apply side effects over an either instance, right? It's providing you the ability to handle both sides. For nullable data, option is a good option, no pun intended, but option is still usable, but it's getting demoted in Arrow because option is kind of colliding with in Kotlin with the nullable or the question mark modifier or the Kotlin nullable types. So in that sense, most of the time they are reflecting the same thing. It's basically the presence or absence of a value. They are raising the same concern, we can say. So in that sense, we are always going to recommend going for the more idiomatic solution here, which is the Kotlin nullable or nullability support. But if you still want to use this kind of monadic style, either is also going to support nullable types. So in that sense, you can use from nullable, which is basically this constructor function that you can call over the companion object that will allow you to pass any nullable value and will return you an either right if the value was found or an either left of unit if the value was not found. And then you can, for example, ally unit to a more strongly typed domain error that you like, okay? Like episode not found or whatever, to be a little bit more semantic, because unit is probably not very explanative or descriptive, okay? Other than that, I mean, you are using either the same way you would use option. You have a map, flat map, and so on, so you can basically keep computing over your data or over the error, you can transform it, and things like that. Why not to use option? Because it's a little bit redundant having the Kotlin nullable types. So we are gonna try to promote the most possible the most direct possible style, which is the one using Kotlin nullability support. Okay. Still, we are going to keep option around. Option is going to be probably moved to a different package because there's a lot of people obviously using it, and there are some libraries like RxJava and other libraries that are not really good friends of null types. So in that sense, option is still going to be there if you want to use it. But I can say that for all the cases where you were using option, you can also use either, because at the end of the day, it's a disjunction. Instead of present versus absent, is left versus right. So you can basically define the same use cases you've been defining for option using either. So you can, if you want to go for either, you can also use either for that. Okay. Okay. This is going to be very important because in Android, we use third-party libraries all the way. Like, I don't know, let's say that you are using Retrofit, you are making a network query, or you are querying a database using Room or whatever. So you have a suspend function that represents your effect, your side effect, and you want to integrate that with either because you want to reflect the result of that operation. You want to wrap it into either. Right? So in that sense, you have either catch. Either catch is an operator in either, which we could understand also as a constructor because it's a function defined over the companion object that allows us to pass any suspended effect to it. So in that sense, you can use it to wrap the result of any suspended effect. It will automatically wrap the result into either right if it goes well, or into either left if it throws an exception. So in case it's an error, it throws, you will get it into either left, that exception, okay? So it'll be left containing that exception. And if it succeeds, as I was saying, it's going to be right containing the actual value. Then you can use map left, which is really handy for integration with third parties because it gives you the ability to map the throwable into something else. So you can map your throwables into strongly typed domain errors, which is also really common in Android because we don't really we are not very used to work with exceptions right away, but we prefer to map them to strongly typed domain errors as soon as they enter our domain. So it makes sense to use map left, in my opinion, for that. Okay, like in this example. So basically with these lines, you can integrate the either data type with any third-party call as long as you reflect that as a side effect using suspend, which is what we are suggesting to do. Okay. Okay, there you go. For composing logics, because we already got means for flagging effects with suspend, we got means for the entry point for consuming the actual suspended logics in our program, in this case in our apps. So probably the only missing piece would be how to compose the different logics. We are using either, most likely, at least so far in the presentation. So we can just map or flat map, use like the standard combinators, we could say, or operators for chaining calls on top of either, or for chaining another either value on top of the initial one, and compose computations using that data type. How does flat map work for either? That's very important also. Well, flat map is basically for sequential operations, okay? In any data type out there where you use flat map, is basically for chaining computations over that data type. So in the case of either, it's just the same. You can have two dependent computations where the second one depends on the result of the first one. So if the first one succeeds, the second one will be able to be performed without any problem and might succeed also. But what happens if the first one fails? Well, in that case, you cannot really perform the second one because you don't have a successful result on the first one, which was a requirement to perform the second one, because both computations are dependent on each other. Not on each other, but the second one depends on the result of the first one. So you cannot ever execute it if you don't have a successful result in the first one, right? So in that sense, you can just skip it. It's some computational time that you are saving because there is no way for you to actually run it. So that's actually called failing fast or error short-circuiting. So in this case, what either does, and if you have your computation, your program as a composition of eithers, you're going to be using flat map. And in that sense, flag map will basically forward the error. If it gets an error as an entry, so it's going to be a left containing an exception or an error. If you flag map over a left, it will just return the same error into left one more time. So it's not going to do anything with it. That is why we say, and also the same thing for map. So we can say that the operators that are meant to work over the happy case or the happy side of either, like map or flag map, those are right biased. So they are only going to apply their computation in case it's a right. Otherwise, if you are not on the happy path, if you are not computing over data, but you are processing an error, they are just not going to perform that computation, but just forward the error as is. Okay. So in that sense, effectively, that means that as soon as you get an error, when you're chaining computations using either flag map, that's the other error you are going to get as the result of the overall composed computation, because it will keep forwarding the error right until the end, as soon as it gets the first error in the chain, right? And that makes sense, because if we are talking about sequential computations, you cannot really keep computing if a previous computation fails. You don't have your requirements, you cannot keep computing, so you can just short-circuit the computation and return the initial error right until the end, right, as the result of the overall composed computation. So flag map works like this. You can, this is very standard, but you can have, for example, a couple of effects using suspend. So they are flagged as side effects. So load speaker takes a speaker ID and returns either an error or the actual speaker. This is still, it's mocked, so you have an idea of how it looks. This another suspended effect also takes like a list of talk IDs, and in this case we want to load a list of a collection of talks by their ID, so it can either return an error or the actual talks in case it succeeds. So for flag mapping, you just make the first request and then you can flag map and perform the second request. So you can see how we are using flag map as a means for chaining a couple of operations or computations that return either in this case, right? The second one is using the result of the previous one to perform each job. So obviously this is a computation that we would never be able to perform if the first one failed. So if the first one returns a left with an error, you cannot keep computing, and the overall composed expression will return left containing that error or that exception. In this case, it's going to be a speaker not found error. Okay, that's the error side on the initial computation. So we short-circuit the computation, we forward the error as is, and it's going to be the result of the overall composed computation. If we are talking about sequential computations, there is also this alternative style, which is either bindings, where you can create an either computational block, we can call it. It's like saying, okay, I'm going to compute with either all the way. I have a bunch of operations that are using either, and I want to run sequentially. So what I do is opening this either block, and then you can use these bindings inside. So you perform the initial computation and you bind over it. And binding it means that you have the inner value for the happy case available right away in that line. So you can assign it to a variable on the left-hand side, for example. So you don't need to explicitly unwrap it. You have access to the inner value already. Remember that this returned either. So if we don't bind, what you will have here is an either. But with the power of bind, we give you the ability to access the inner value only for the happy case. So you can use it right away in the next line without any sort of callback style or nested style, right? You can use it in a more direct style. So you perform the second operation, and you can also bind to access the inner value right away on that as a result, instead of the wrapped value into either, okay? So that's really cool. Maybe not, probably not really big improvement in this case, because we only had like a couple of computations, and it might be simpler to just use flag map, because this is flag map under the hood. The arrow compiler plugins or annotation processors are basically translating this to a chain of flag maps. So it's just basically the same than this, right? But in this sense, if we only have a couple of computations, it's probably simpler to go with the standard flag map style. But it gets more powerful when you start having more computations, like in this case, right? The more computations you have, you start feeling that this style allows you to have like a single level of indentation and a more direct style where you work more like synchronously, we could say, instead of using this nested or callback style that you get with FlatMap. So in this case, let's say we have the initial operation for loading the speaker, another one for loading the talks, taking the talk IDs from the speaker that we have just loaded from network, and then another one for loading the event details for the event of each one of those talks. Okay, so overall we have 3 sequential computations that we want to sequence, to chain. All of them are returning either. So again, we can use this either block and use bind, right, on each one of those. So we get access to the inner value right away in the left-hand side for each one of those. And you can encode the whole program, which in this case is chaining 3 different computations that return either, but with a single level of indentation, or a very sync-like style, we could say. So about failing fast or short-circuiting, this is something we mentioned. What happens if you get an error on the, for example, on the initial computation? So what you get is a left of a speaker not found. That is an error already. So that's basically moving us out from the happy path to the left side, to the error side. So that's going to short-circuit the whole computation. It will just not perform this computation, neither this computation, but just return left of a speaker not found as the resulting value of the overall block. Okay, so it basically short-circuits the whole thing. It doesn't compute further, and returns that initial error as the error as the result of the overall computation. Cool. So if we think about programs, I mean, we think about programs out there many times, or the big majority of the time, you can think about those as a composition of functions that might succeed or fail. So in that sense, you can reflect any programs as a composition of computations that, or functions that return either. But in that case, we are talking about sequential computations, as we've been saying. So computation always depends on the result of the previous one. And ultimately, any programs are basically a sequence of computations, right? Because you have a computation, you have an operation that maybe goes to network. In Android, right, if we focus in Android, maybe you are going to network and then you want to map the errors, and then on top of it, you flat map because you want to apply another computation on top of that data. And you keep mapping and flat mapping other way, depending on the amount of layers you have. But at the end of the day, you're going to have like a chain of either's, right? So in that sense, you can reflect any call stack or any logic in Android using the either data type, most likely, unless you want to go for something like streams or something that we are also going to cover today. Then you will need a different data type. But in the case of one-time or one-shot calls, either is more than enough in combination with suspend, right? Because that's what is going to give you the safety for side effects. But what happens if you want to accumulate errors, right? When you are running independent computations, that doesn't make any sense, because if you get an error in the initial computation, you cannot really perform the second one or the next one in the chain. So there is not such a scenario where you have many different errors, because the first one is the one that you are going to keep. But in the context of non-dependent computations, like for example parallel operations, you could actually be interested in all the errors, like gathering all the errors for, I don't know, if you're, in the case of Android, you want to gather all the errors for validating a form or something and show feedback to the user all at once, instead of giving feedback for each one of the, like validating each one of the fields separately, calling the server, getting the result, giving feedback to the user, like field by field. That's not ideal. What you prefer is obviously validating everything all together and provide all the errors together to the user. So in that case, you want to perform all those operations independently, potentially in parallel also, maybe, and gather results in the end, and also gather all the errors in the end in case there are one or many errors. So either is not great for that, it's not defined for that, and for that you have validated, which is a different data type. If you remember, we've been saying that data types raise a concern over the data. In the case of either, it raises a concern of the data being success or fail. So you have this duality. And in the case of validated, it's more like valid versus invalid. That's what it's raising. And validated provides us this type alias, which is validated nil, which stands for validated non-empty list, which is the one that is able to accumulate errors. So that is the same as validated of a non-empty list of errors or the actual valid result in case it's valid, right? So in the case we have an error, we always need to have at least one error, and it's able to support a list of them. Okay, that's why it's able to accumulate the errors. And we also have operators here for mapping and flag mapping and all that. I'm just simplifying it here so you have an idea of how it looks structurally. So here is an example of how you can use validated nil for error accumulation. Let's say we have another couple of effects, okay? One is for loading the speaker by ID. In this case, we return validated nil. That's the concern we are raising. In the case there is one or many errors, we are going to map all of them to speaker not found, a single type. Otherwise, we are going to get the actual speaker. So, well, we can go like, okay, validated catch nil. If you remember, we were using either catch before for integration with third parties when we want to wrap the result into either. In this case, we want to wrap it into validated nil. So you can use validated catch nil. That's basically going to allow you to put any suspended effect inside, run it, and automatically wrap the result into validated nil, right? So the result can be a successful value. In that case, it's going to be a valid containing the value. Otherwise, it's going to be the actual non-empty list containing the error on the left side, because we are mapping any possible exceptions on the left side. We are mapping them to a strongly typed domain, error domain that we want to use, like in this case, speaker not found. And we have the same for load events. We have a list of event IDs in this case, so it's going to return maybe an invalid IDs error or the actual list of events if it was able to retrieve them. So you can validate a catch nil, put your network wire inside, so it's going to lift the result into valid with the list of events if it's correct, or invalid with the list of errors in case there was any error. In this case, it's going to have a single element. And then you can go like, okay, I'm going to use validated tuple n to run both computations, and that's going to require an error accumulator, which you can create this way. So the error accumulator is like an accumulation strategy for your errors. So and we do that using this instance of non-empty list for the error data type. Okay, so you pass the error accumulator, you pass both computations that you want to run independently, and that's automatically going to give you either a tuple. Sorry, it's going to be a valid containing a tuple of all the successful results if it's correct, if all of them are correct. But if there are any errors, you will get an invalid containing a non-empty list of all the errors. So this is just an example, so you can see the validated nil is probably the good pick or the right pick when you are going for error accumulation instead of failing fast, because you have non-dependent computations, okay? When you have dependent computations, this is not possible because you cannot really keep computing over your data if the previous computation failed, okay? So you always forward the initial error right until the end. Okay, so, well, so we have means for encoding sequential and parallel or non-dependent computations, and you can imagine that any logics we can have in Android or any programs out there are ultimately a composition of the two. So it's always like sequential and also many times parallel or independent computations. So in that sense, we kind of have like all the tools we might probably need for writing any logics in Android, any pure logics, because we can use them in combination with suspend, as you've been seeing in these snippets. So as soon as you flag as long as you flag your effects as suspend, you will be sure that the compiler will not allow you to call them from anywhere, and you are going to have this requirement calling up the call stack, and the need for providing this runtime for consuming the program. But what happens if we want to use threading or concurrency? Because we've not said anything about that. These data types are eager. They are running their code as soon as you create them. But what happens if you want to run the code in a different thread, a different coroutine context, or even parallelize requests or things like that. That is where the Arrow effects coroutines library comes into play. This is like the library Arrow provides for effects, okay, for working with effects. So all the stuff regarding effects is going to fall into this library. And it's basically like a bunch of operators, of functional operators that work over suspend. Okay, so all the operators expect suspended computations because they are meant for running suspended effects. So you will see that all these operators are expecting suspended lambdas to be passed to them. And these operators are all also suspended, right? They are also defined as suspend functions because we don't really want anybody to be able to call them if it's not for running effects. So we cannot allow anybody to call them from anywhere, but only from a context or at a runtime, as we've been saying, that is prepared to run suspended programs. So it also provides collaborative cancellation. All the operators you are going to see here, and also the ones that we are not showcasing today, are automatically supporting cancellation by themselves. So as soon as the parent scope or the parent coroutine gets canceled, they will check for cancellation and cancel themselves and their children jobs or their child tasks. So all that is going to work automatically for you. The environment is, we said a couple of words about the environment, and it's basically provided by ArrowFX coroutines. That's why I am mentioning it here again. But as we said, it gives you the ability to pick the execution strategy. So in case you are going for the environment, you have functions to run the program synchronously. So it's going to be blocking asynchronously. So you can put it in there, your suspended program, and then you have lambdas for the error and the successful sites. And also the unsafe run async cancelable strategy, the asynchronous strategy that is cancelable. That's going to return a disposable that you can invoke from anywhere to cancel the execution of your call stack, right? And the environment is an actual interface, so you can implement it in different ways. If you want to provide or support your own runtime for Arrow, it's possible for you to do it using that. But as I said, the environment will be deprecated most likely for CO12 because we are going to provide the direct integration with Kotlin X coroutines, so you will be able to use the coroutine scope and the structured concurrency for driving cancellation. So you can use the coroutine builders from Kotlin X coroutines for creating this environment instead of, or this runtime for your suspended program instead of the environment from Arrow, okay? Some operators of RFS coroutines. Evalon is basically an operator for evaluating something in a different coroutine context and getting back to the original one automatically. So you can imagine you can put any suspended effects in there. For example, here we are evaluating on the IO pool this effect that uses either catch for going to network and capturing any potential exceptions thrown into either left or the successful value into either right, and then we map the potential exceptions in case it failed to some strong domain error type, right? So the result is going to be either of these error or a list of the actual talks. So in this sense, we can use Evalon to pick any context to evaluate our effect, our suspended effect in there, and you can put any other operators from RFX coroutines in there because all of them are suspended, as we've been saying. Okay, this is getting replaced by with context whenever we provide this integration with Kotlin X coroutines because it makes a lot of sense. I mean, both of them are basically doing the same thing, so this is not going to be needed anymore. But in case you are still on 0.11, which is most of the people already, because that's the latest release, stable release we have, you have eval on, okay, for doing this. For parallelizing requests, there is parmapen or parttupled n, so it basically allows you to run n suspended effects parallelly or multiple suspended effects parallelly. So in this case, for example, we are parallelizing a couple of effects like operation 1 and operation 2, which are explicitly lifted as suspended functions with this suspend constructor, which is part of the standard library in Kotlin. So that's a way you have for converting a standard function into a suspended one. Let's imagine these two are not suspended functions for any reason. So you lift them into suspend, you make them suspended and run them into Parma. if the functions are suspended, so if the effects are suspended already, you don't really need to leave them or anything like that. Just pass them to ParmApp and go ahead. And you basically get all results as the inputs or the arguments for this callback lambda you get, where you can compose, for example, a model out of all the results or anything like that. So basically, the result of ParmApp is going to be the result of this block. So this is really, really, really handy because you can parallelize many different operations. This is only parallelizing 2 of them, but it can be many more. And it allows you to do this pattern of waiting for all the results. This is basically using async and await, the way you can do the same thing with Kotlin coroutines under the hood. That's what it's going to do, starting on 0.12. So it's going to be more like an alias, one for the other. ParmApp is more like the naming functional people is used to. So for now, we are going to keep it, but they are going to be basically the same, right? So you could represent this using Kotlin coroutines, using async for each one of the asynchronous tasks there, or each one of the suspended effects there, and then await for all of them, for awaiting for all the results, and compose the event, in this case, with all the results. There is part-tupled n, which is more like inline, because it allows you to basically call it in this kind of like inline style, and it gives you the results as a tuple. Okay, so it's something you can use, for example, along with destructuring, so you can assign each one of these elements in the tuple to a different variable, in a single line or things like that. So you can do the same thing you did with ParmApp n. There is this part-tupled n variant, which is just the same. So how does it work for cancellation? Well, as we said, all the operators check for cancellation by themselves. So if the parent gets canceled, if the parent coroutine here gets canceled, or running this suspend function gets canceled, the ParmApp n gets canceled, and also all the children get canceled at the same time. Okay, so there's always this implicit parent-to-child relation when we are working with cancellation. In the case one of the children fails, the other ones are also canceled. This happens because this pattern is about the fact of gathering all results to create like an overall composed thing in the end, or composed model in the end. So you kind of like need all results succeeding. So as soon as one of them fails, ParmApp n or part-tupled n automatically cancels the other jobs. Okay, that's obviously something you can bypass. If you don't really want to rely on this automatic cancellation whenever one child dies or fails, meaning it throws, you can, for example, handle errors within each one of the computations. If you handle your errors here using either catch or something, this is never going to throw because you are capturing all the errors, and also here. So in that sense, the operations always succeed for ParmApp, and you can bypass that automatic cancellation in case you want to do manually, because you are interested only on some of the results in case some other results fail or whatever. That's nice when you have a number of suspended effects that you are aware of. Like, for example, you have 3, so you put ParmApp n and you put the 3 effects right there. But what happens if you have a list of elements and you want, so it's like a dynamic amount of elements and you want to run an effect for each one of them, but all of them in parallel, and wait for all the results in the end in the same way we were doing with ParmApp. There is part traverse for that. So part traverse allows you to take a list of, for example, of IDs in this case, and then you part traverse over it. You have the chance to provide a context, for a coroutine context, and you can run one, an effect for each one of those values, all of them in parallel. So in this case, you will be loading the event all the events by their IDs, all of them in parallel, and wait for results in the end. The result of this is a typo. I will show here the result type that is going to be a list of events in this case. Okay, the result of part traverse in this case. That's for a list of elements where you want to run an effect for each one. But sometimes you already have like a list of effects, right? Like a list of suspended functions. And in this case, you can just part sequence, and that's automatically going to run all of them in parallel and gather results in the end. All these operators provide you the chance of omitting the dispatcher or the coroutine context. So it's always going to run in the default one by default, the actual dispatchers.default from Kotlin coroutines. And but you can also pass one explicitly, as we are doing here. Okay. What else? There are also operators. I mean, I'm talking about a lot of different operators in arrow, effects, coroutine, but you can imagine there are many more. There's not going to be time for all of them, but there is the chance also for erasing effects or suspended effects. So you kind of keep the winner and cancel all the losers. So you provide a bunch of different suspended effects, and you need to fold over the result, because that gives you a data type that you need to fold over, because you never know if it's going to be which one is going to be the winner. You don't know if it's going to be the first one, the second one, or the third one. So you provide lambdas for all of them with fold. And the cool point of this is that it keeps the result of the winner. So you keep the result of the winner, and the rest of the the losers are cancelled automatically. Okay, by raise n, the raise n operator. Again, it automatically checks for cancellation. So if the parent coroutine gets cancelled, raise n gets cancelled. All the children get cancelled, and the same for all the operators we've been seeing until now. Okay, that's the same for all of them. So you can see how cancellation is very simple in the world of these functional operators. It's not convoluted at all, because it's always from parent to children, and if a children first, you cancel the others. So it's like the same thing for all the operators, and that makes it much easier to reason about, because sometimes in the world of Kotlin X coroutines, it's not that easy to use a structured concurrency. You know that there are like a lot of gotchas when you're using coroutine scopes, supervisor jobs, depending on where you install it, it does something or something else. So a lot of knowledge overhead you need to have. And in the case of functional programming, since we really want to achieve certainty and being deterministic, we wanted to pick like a more coherent cancellation strategy for all the different operators we provide. So you don't need to remember, depending on the use case, what you need to do, right? A use case for races in Android, for example, could be binding a task by the activity lifecycle. So you get it automatically canceled when the activity gets destroyed. So you can be creative and, for example, do something like this. You can use a lifecycle observer for along with the suspend coroutine from the standard library. So you can wrap your observer call into a coroutine, and you are gonna continue the suspended job that is calling this method only when you get an onDestroy signal in the activity or an onDestroy event in the activity. So you are basically suspending the execution of this task until the activity gets destroyed. So that's one of the jobs. We are going to have a coroutine that gets suspended until the activity gets destroyed. We can basically raise that against our long-running job that is also a suspended computation for loading, I don't know, an integer value in this case, but you can imagine it could be a more meaningful data, like a list of users or whatever, to render on a screen. So in your activity, you could basically raise n both tasks. So if the onDestroy happens or takes place first, it will automatically cancel the other one, my long-running task. So I'm effectively bounding my long-running task by the life cycle of the activity doing this, because if it gets destroyed first, it will cancel my long-running task in that case. If it's this one, the one that completes first, it will cancel the one that is awaiting for destroy, which is totally fine. Okay? So races have different possible or potential use cases. It depends on how imaginative or creative you want to be, or you can be on how to use it. That is only an example that we could use in Android. For repeating or retrying suspended jobs, there is retry or repeat. So for example, retry, you have the chance to pass a policy to it that I'm going to show you in a second how to build and fit any suspended effect in there. To create the policy, you have a very powerful and reusable and composable DSL, like the schedule one. So for example, you can create a schedule that is exponential for an exponential backoff that starts at 10 milliseconds, and I think it has an implicit growth factor of 2, but you can pass an explicit 1 if you want to. So it's going to be an exponential backoff starting on 10 milliseconds that will keep growing while the output stays under 60 seconds, and then you're going to recurse up to 100 times, one every 60 seconds, for example. So it's a complex policy that you can create that returns an instance of a schedule that you can basically use it with retry to retry any suspended effect that you want to feed in there. So this is really cool because you can inject it. You can generate it, your policy, and inject it everywhere. So if you have a bunch of network requests or, I don't know, database queries or whatever side effects in your system and you want to reuse the same retrying policy, I think it's a really good practice, okay? Because you can inject this schedule and use it everywhere for all your suspended tasks that you want to apply the same kind of retrying policies to. There is also repeat, because the retry keeps retrying meanwhile the effect throws. It keeps retrying it as long as the policy is not over or it doesn't succeed. And there is also the opposite one, which is repeat. Repeat keeps repeating it even if it succeeds. It keeps repeating, but the syntax is the same one. You pass it a policy, so it keeps repeating until the policy is over, or until it throws, okay? As soon as it throws, it stops repeating it. So a couple of operators there, retry and repeat, but you can see how powerful they are, right? The cool point, again, is that they are expecting any suspended effect in there, in the block. So you can use any other arrow operators that are suspended, any other arrow effects operators in there. For error handling, you can imagine that as long as you are using suspend and you're using either or validated, you can put your either catch or your validated catch or your validated catch null at any level of your architecture, depending on how granular you want to be with your error handling, right? Because you can install smaller error handlers per layer, or I don't know, a global one for a bunch of layers together. It depends a little bit on your architecture design or how you want to do it. But given they are expecting suspended code in there, you can basically put them at any level you feel appropriate, regardless of the operators you fit inside. Okay, so it's like very coherent. About the streams and functional reactive programming, well, you know that we are very used to streams. That's probably a long story, so just a couple of slides before finishing, because I think it's probably already quite a lot. But yeah, we also have streams in Arrow. Until now, I mean, we call them the functional streams because we want them to be able to evaluate functional effects, meaning by that we want them to support all the functional arrow effects operators we provide in the library. So we want the stream to be able to evaluate an effect using any of these operators like parmap or whatever, or raise or whatever operator from the ones we've seen, and emit the result over the stream, right? And then keep computing over it using the stream operators and all that. So in that sense, the data type needs to support that, all the RFS coroutines operators, so we can use it functionally and obviously allow things like declarative programming, call the streams, composition, and all that. We had an arrow stream that we still have in 0.11 that we are deprecating, that is basically going to be replaced by flow, because we decided that it doesn't really make a lot of sense to provide a separate data type when flow is really, really extended already in a lot of code bases. So it's probably smarter to bring support for flow, and instead of providing a different data type, keep using flow and add all our functional operators on top of it. So we are going to do that. We are going to take all the operators we had, but port them to be extension functions over flow, defined over flows, so you can also work with flow in a functional way, right? And use both libraries together on integration seamlessly. That's going to come in 0.12, if I'm not mistaken. So in the upcoming versions, for now, if you're using Arrow and you're using streams, you know that the stream data type provides the ability to evaluate effects, as you see here. So you can put any suspended effects in there containing any of the arrow effects operators, as we've been seeing today. You have means for recovering from errors. There is effect map, for example, for chaining another effect afterwards, map, all that kind of stuff. And then you have the terminal operators for consuming it, which are suspended. So you can see a big similarity here with flow if you're used to, right? You have collect in flow that is suspended. And because you don't really you shouldn't really consume a stream if it's not from a place that is prepared to run suspended effects, or in other words, to run side effects, because at that point you are consuming the pure program. At that point you are effectively applying and running all the side effects. Before that point, you're safe. Everything is pure. Everything is declarative. Its code is awaiting to be executed or to be consumed, right? So again, we see this concern separation really clearly. We have our in-memory program, which is like composed of all these operators. In the case of arrow stream until 0.11, it was like this until here. All that is called and declarative and waiting for you to consume it, and then you decide what or which terminal operator to use to finally or to ultimately consume the stream, right? What else? Well, if you get an error in your effect, because you can always get an exception thrown, that's going to be lifted into the stream so you can recover. Basically, it's going to be represented into the stream data type, so you can use your recover methods. In this case, they are called handle error with, but you can think about this more like the standard recovery errors, recovery operators that you have in other libraries like RxJava, for example, to kind of get back to the happy path when you get an error. So yeah, I mean, there's much more than this. That's only like a very simple subset of the operators you got there, but there are things, there are support, other features for, supporting things like scoping the usage of a resource across the life cycle of a stream. So you get access to that resource all the time over the stream, and then when the stream terminates, it makes sure that it's not leaking, so it closes that resource, releases or disposes that resource in the end. So that's really cool to work with any kind of resources like databases or WebSockets or files or whatever that you want to close in the end after using them, so you don't leak. But also things for running streams concurrently, parallelly, things for integrating streams with a schedule, so you can also repeat and retry using all that kind of repeating complexity or logics we've been explaining, or operators we've been explaining today, also along with streams and much more. Also races and more. All that is going to be supported over Flow, or at least all the relevant operators, because many times, as I was saying, Flow already supports them with a different name sometimes. So obviously in those cases, we are not going to duplicate them or anything. But we are going to add all the functional operators on top of the Flow APIs already, or at least all the ones that make sense. So you can use both libraries together on integration without any problem. So that's it. Sorry, because it was a quite long talk. I thought I had asked as much as I needed, but it looks like I need to ask a few more slides to make it a little bit less rushy. But thank you very much for being here. I want to say something else before the organizers take it over, and it's that we have a course for explaining functional programming from 0 to 100. So it's like a fully fledged functional programming in Kotlin course using Arrow, not constrained to Android, but for any Kotlin platform. So that's also valid for backend. And that's happening starting next week on the 19th. So we only have a few slots left, but I definitely recommend it because it's a 4 days long course that is really, 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 really carefully designed. I'm going to be the teacher for all the lessons. So it's 4 days, 4 hours a day, where we go over all the functional concepts one by one with theory and exercises, and we have time for any sort of discussions on everything. So it's totally recommended. You have the link there, and that's pretty much it. I will share the slides on Twitter also. You have my Twitter there. Thank you very much.
Thank you. And I attended your workshop on functional Android a few months ago.
Oh, nice.
It was really cool. So definitely go to check all the other courses that 47 Degrees done, especially the one from Jorge. Cool. I think we have a few questions. There you go.
Okay.
Can you see them?
What is missing for 1.0 release of Arrow? Okay. I think the biggest deal in there is the Kotlin IR, the new Kotlin IR that was released with 1.4, but it's still not solid or stable. So until the new Kotlin IR is completely stable, we depend a lot on that, I'm afraid, because there is a raw meta which is gonna provide a lot of utilities using compiler plugins, and that's definitely depending on this new IR. I need to double check if that's still in the roadmap for 1.0, or maybe we are pushing it further. So I'm not gonna say take this with a grain of salt, okay? Because I'm not completely sure. But that's a big dependency we have, and if it's not for 1.0, it's gonna be for 1.01 or something. But we'll need it. What else? We are in a big refactor to remove a lot of complexity from Arrow regarding type classes and higher kinds, because we want to make it much more accessible. So you can use Arrow more like only thinking about the data types and the operators on the data types, instead of knowing like functional programming in depth and all that kind of sometimes too high level of abstraction concepts. So in that sense, there is a big refactor ongoing that needs to happen before that. Also, porting the streams to use Flow instead. So a few things that are happening there. If you want a date, I don't have a date, but probably I think the aim is most likely like first half of the year to be done with everything. But again, take that with a grain of salt, because there's a lot of development under works right now. Another question: my Android app is full of side effects. I want to start adding FP to it. How I start? Okay, great question. In my opinion, the best way to start is flagging your effects as suspend. So I'm not sure what's your level of integration of Kotlin-esque routines already in your app. Hopefully you already have that up and running. So in that sense, you are already using suspend. So it's more about, for example, going to the leaf nodes of your call stack, like all those network queries and database queries, and transform those into suspended calls instead. And then you can start using data types like either, for example, for the computation stat that work with that data. Like, for example, if it's a network request, you make it suspended, and then you wrap it into either catch. And there you go, you are already using kind of functional programming somehow in that sense. You are using a functional data type, you are wrapping your request. You can use map left for all the error mappers, which is also really common, and probably you're already doing, but using standard mappers. So you can use it within map left. So my recommendation is to do it like probably per feature, to not try to face very, very deep refactors only by yourself, because that's not going to work. But it's always super important to have more people on the team with this knowledge, because otherwise it's a battle that you need to fight alone, which is almost impossible most of the time, because you're learning the concepts at the same time. So it's almost impossible for you to support and give good explanations about everything to your teammates and at the same time learn everything. So I think it's totally recommended if you can get more people supporting you with this knowledge. In that sense, we obviously offer courses and all that in the academy. So we are always open for talking about agreements between companies or things like that. What else? Another thing is not serializable. How can I have the left and right side approach in a seal class and also make the data classes in that seal class serializable too? I think you need, I will need to think a little bit about this, but I don't really think you want to serialize like the whole thing. You don't want to serialize the either containing the data. So left with the error or right with the actual data. What you want to serialize is the successful data when you get it. So probably you need to refactor a little bit your code in that sense. So you don't need to, because you don't want to serialize the whole structure the same way you will not serialize option or anything like that. Maybe you need to redesign your code a little bit in that sense. I'm not sure if you say maybe for passing data between screens on the intents using bundles or things like that. Depends a little bit on the use case, I guess. I'm using a nested lambda with coroutines. Isn't that callbacks? Well, I don't know what you're referring to exactly here, to be honest. I don't know. Maybe you want to ping me later on in Twitter or the Kotlin Lang Slack group. That's probably going to be easier if we have a conversation there, because I'm not sure what you're referring to exactly. Sorry. The final question, so I don't leave any questions left. Since either is now our suspended friend, does IO still have a place? No, I mean that's actually the point. For the people that is not familiar, we had IO before that got deprecated already, and it's a data type that is meant for wrapping suspended effects, for making them pure. So what you do by wrapping your suspended effect into IO is effectively deferring it. So it's becomes more like a description of an effect than the actual effect. But in that sense, we are replacing IO with suspend. So suspend is the keyword now that takes care of your side effects. It's flagging them so they can become compile time safe. The compiler is aware of them because it's a keyword in the language that is primitive. It's a primitive keyword supported by the compiler, so it already knows what it is and all that. So we can ensure that we have the same guarantees we could ensure with IO by using suspend. So it's more like replacing one with the other. And if you try to start migrating your code base from IO to suspend, you'll see how it becomes much simpler, because you effectively remove one of the wrappers over your data. So you don't need to start explicitly wrapping or unwrapping anymore. You are already working over the inner context or the inner value when you move towards a suspend style. So thanks for your talk. Question about your training course during the 4 days. What is the percentage of practice on functional programming? It's 4 days, 4 hours. This time is for the European time, so it's going to be in the mornings, starting at 9 every day. And the percentage of practice, I'm not sure if you refer to the experience you need to have. In that case, it's beginner, so you can go, if you only know Kotlin but you don't know about functional, that's the best course you could do, probably, because we start from the very beginning. And if you mean how much we use it in practice, we have exercises for each one of the lessons also. So all the concepts, we put them into practice. So I hope it's very rewarding for all the people doing it. And that's it. Thank you very much to everyone and to the organization for letting me be here today.
Thanks to you for this always very interesting talk. Thanks so much. Okay. So I think that's it. Thanks again to the two Jorge for being with us today. You can find them on the Kotlin Lang Slack, especially Jorge Rego. You can find it on Ktor, and of course Castillo with Arrow. Thanks so much for tuning in, and hope you enjoyed the talks. Remember that you can rewatch them on the YouTube channel. You can watch also the previous talks that we hosted. For me, Guillermo Pablo Amar, have a good evening and stay safe. See you on February the 2nd with more Kotlin talks. Bye.